Thank you, thank you, thank you. Happy to be back. You know it, we're here to talk about solar power for risk engineers. It's been a while. We actually haven't talked about anything to do with solar. We talked about a little bit about renewables, but let's get into it. So one of the things that you'll find if you start to look at solar facilities, that your biggest risk is going to be snake bite. Be careful, depending on what part of the country you go to and depending on how well they maintain the grass. That was one of the biggest threats to people doing these risk surveys. Alrighty, so what are we looking at? We're looking at a solar field with the photovoltaic modules. We're going to kind of take you through what all the components are of a solar farm first, and then we'll get into what can go wrong with the components, what can happen to them, and then we'll talk about how to manage those risks and basically what solar energy loss control is. So after the solar modules, we have the power that comes out of the modules is in direct current, so we need to invert that to AC current. There's actually one step before the modules. It's called the combiner. So the modules are in strings, and the strings all get combined before they go to the inverter, and then the inverter puts that DC voltage to AC, and then the AC voltage gets over to our step-up transformers, and then it gets elevated to the grid voltage so it can be transmitted across the grid. That's the basic components of a solar farm, not to mention the control room and the control buildings. So what are the typical threats? What can happen? Well, obviously hail. That's a big problem. We have glass aimed at the sky, and sometimes the sky just opens up with ice. So take a look at this. At the time this happened, it was the largest hail event in the country and the world. To a solar facility, anywhere from $50 to $70 million, depending on how that settlement worked out. But if you notice, not every single panel is destroyed. And this can cause problems for folks who aren't used to solar hail interaction. But what can happen is the adjuster will look at those panels that don't appear to be damaged and just make a blanket statement that they're not going to pay for them because they're not cracked. Well, you can't see microcracks. So whether they're covered or not, it doesn't mean that that panel is a good panel going forward if it's got microcracks. So we'll get into microcracking later. But and if you want to know why solar panels do this, leave a comment, ask the question, I'll explain it further. But it's a fairly simple explanation as to why we don't see all the panels destroyed at the same time.
In the solar power game, it's all about the sunshine. But what happens when nature plays hardball? When rain turns to hail, simple drops of water become millions of frozen wrecking balls. When hail threatens your power plant, every minute counts. Meet NX Horizon Hail Pro, the new gold standard in severe weather management. Storm approaching, potential for hail in your forecast. With Hail Pro, you're prepared. With a single click, dispatch an immediate stow command to the entire power plant. Or let our software go to work using automated forecast-driven stowing. In a matter of minutes, trackers rotate into hail stow position to minimize impact. The storm fades. The sun returns. Trackers back in action on your mark. Rest easy knowing your project is equipped with best-in-class hail solutions.
That's right. That is one option, and it might be a retrofit option. One of the things, I haven't even heard of whether these are operating yet, so if you have in the comments, please let me know. Love to hear about their effectiveness, how they work in hail, how they work in wind, and just if they've actually worked. That'd be great to know. So we have to deal with hail and wind, and they have a wind stow system as well that is designed to, instead of angle the modules in a way that the hail won't hurt them, it actually lays them flat so that the wind won't hurt them. Well, that wouldn't be very good for hail because then the hail could hit them. So they need to be in different positions for wind and hail. Here is a just some raw footage of a wind event that occurred in North Carolina, one of our clients. It's just widespread, it's minor, but it all has to be addressed. And again, when you have an event like this, don't be focused on just the bent and obvious broken parts, because all of those panels suffered some sort of vibration in that wind, and you need to determine whether they have microcracks or not. All right, this is what a wind stow system is not. Pretty much destroyed. Doesn't look like it had much lateral or diagonal support on those yet. Maybe it was under construction. Alrighty, another thing that can happen is flooding. We see flooding, especially an issue with the foundations and the footers of the facilities. A lot of times solar farms might be built in land that's not desirable, and it can flood. So it's an issue. I haven't really seen a claim where we've lost an entire production or the entire site's production because of a flood. Wildfires. Now, wildfires can get us. In fact, I had a request to help come up with some sort of fire protection that would respond to a wildfire as if the solar facility was guaranteed to be exposed to that wildfire. So in other words, we're not going to take credit for any of the defensive measures that we have, keeping vegetation cut down and apart. So we're not taking credit for any of that. We're just going to assume that it catches fire. And then what do we do? Well, that's an interesting problem. If you have any suggestions in the comments, send them out. We all want to get this discussion going. All right, so what would be contributory towards a wildfire loss at a solar farm? Well, your own vegetation practices. Do you let grass grow up beneath your solar panels? You know, it's sad when you have to go out the day before the insurance company gets there to check and see, is the grass short enough for when they get there, because you just don't know if your contractor is providing you the service on a time basis that they're supposed to. It seems like the timing is always wrong whenever your insurance guys go out there. So anyway, you may want to send someone out to check the height of the grass, because this is one of those obvious things that we can control and that does lead to losses. The whole facility could get lost if this thing catches on fire. We don't want that. All right. Now, what are some ways to manage the risk as engineers? We're not just going to look at this and go out and mow the grass. As engineers, we can model the fire spread. And there's a couple different models, and I put the names up there. I haven't used these models. I've used other models for firefighting and fire protection questions that we needed to answer. So that's what happened here. Was we had this question, and I wondered, were there models that could help us understand the spread of fire across the wildland into a solar facility, and was there anything in those models that we could take advantage of, like the width of roads? Can we make our roadways wider? Does it matter if it's a gravel road or if it's a macadam or asphalt road? Things that you will learn as you work with the models, but that will help you figure out whether it can solve your problems or not. All right, and talk about solving problems. This is what we've seen out there as one way to manage vegetation in the locations where it's just hard to get the mowers in there. These guys want to get it. You got to watch out. They like to climb on top of things, and from what I understand, you have to be careful about them chewing plastic, so they might chew your cables. So it's just a thought. Don't know if it actually works. All right, now we're going to get into PV fires, the photovoltaic fires. That's fires that originate from within the solar equipment, not fires coming from nature. Let's talk about what can cause those. Just a couple things. Oh, yeah. All right, I'm saving you the shuffle of another 10 slides by putting all these causes all right here for you to see. But basically, if you can keep your electrical equipment clean and tight and cool, you're not going to have all these problems, right? You're going to have design issues possibly, and lightning strikes, and power surges might happen. Pest intrusions are a matter of keeping it clean. So keep it clean, cool, and tight, and you're likely not going to experience some of this stuff. These are combiner boxes. That's the connector. Just one bad connector gets this one started. Another combiner box. They seem to stay where they start. They're very hot and intense, but it doesn't look like there's much fuel left near them to propagate a spread unless there was dry grass underneath them, and then we lose the whole facility. Keep the grass mowed. All right, let's talk about microcracking. It's been all over the board. When I first started getting into solar losses, it was a thing. Then it started being excluded. Now I'm hearing that there's sort of forms of coverage coming back. So just what is it? Well, microcracking, it can come from many different sources. A lot of times that, in the insurance world, we think of hail, but really there's a multitude of events or stress initiators that can cause these micro cracks. The micro cracks are just too small to see with our eyes. And we can see them under a microscope, especially with special lighting like electroluminescence, crack detection, LCD. We'll talk about that in just a second. So why would, besides manufacturing defects, how can the environment, besides hail, cause microcracks? Well, when you have a piece of glass in the wind and the wind is blowing across it, it vibrates, just like a reed does in a trumpet. You may not hear the vibration and the frequency might be low, but you're vibrating. So when you have a piece of glass that's vibrating, it can crack. Take on top of that this piece of glass gets heated up in the middle of the day and it's aimed right at the sunniest part of the sky to get most of the sun. It's getting most of the heat too. And then at night it gets dark and it gets cold. So this glass is heating up, cooling down, and it's being buffeted by the wind. So you've got just a multitude of environmental factors that can cause the microcracks. After they get manufactured, they get put on the ship, and then they're going down the road. You don't think that truck hits a pothole? Yeah, all of the components that come to your facility travel across roads and railroads, in airplanes, so they're going to be subjected to shocks and bouncing. And then the installation of these things, we actually see folks using hammers to hammer the panels down and get them aligned. They'll tap on the sides of them. Come on, folks, that's an installation potential causing the microcracking. Now, what's the difference? What can a microcrack do? Well, it can affect the energy output, because as the panel expands, when it heats up, these cracks expand as well, and they grow. But while they're expanding, they're reducing the efficiency of the panel, because the panel's not all together. There are these gaps in the panel. The increase in resistance because of those gaps increases the heat. The panel gets hotter. And as the panel gets hotter, it gets less efficient. So these things occur right away. And then what happens is, since the panel got hotter today than it did yesterday, the crack grew a little bit more today. And then it cools down at night. And then tomorrow it gets longer. So each day these cracks grow and grow. And before you know it, our output is affected by it, right? So we're losing the total output each day, but the lifespan output is also going away, because we're not going to run as many years as we thought we could, as we originally designed it for. So how do we deal with it? Well, you can detect it with electroluminescence. What do you do once you detect it? Well, if it's an insurance claim, the insurers, depending on coverage, will replace that. If it's not, if it's just a matter of routine inspection, or it was not related to an accident, in other words, it actually was wear and tear, something that was avoidable, preventable. In that case, then you still want to know about it. You're going to want to monitor it for overheating, and you want to track its output, and at the right time decide whether you need to replace it or not. So there needs to be some sort of tracking of your microcracking across your facility. It's important to know that. Let me say that the carriers don't want to pay for pre-existing damage. So if you've got clean, good panels, it's great to have a set of your electroluminescence slides or photos that prove that you don't have any microcracking going on in your panels. Because then when you have a weather event that occurs and you go out to the facility, like I'll tell you about later, there's no direct evidence that an event occurred after you get there. So now you have to rely on detecting those microcracks. Whoa, we got a screen issue going. There we go. So in loss control, we talked about what you can do, hail stow, wind stow. We talked about ways for vegetation control, whether you mow it or whether you bring in livestock to do that, but you have to have some sort of inspection program to make sure that it is actually being done on time. It's one of the most important things you do to protect the life of the facility, to prevent the maximum foreseeable loss, to keep from having the entire system burn out. And then electrical tests. We'll talk about dissolved gas analysis and electrical tests. They're going to be for your transformers, your inverters, your combiners, all your electrical equipment. You're going to want to infrared scan that equipment and make sure that it's not overheating and that you don't have any loose connections. And when I say infrared, don't fall into the trap that a lot of solar operators think that means a drone flying and scanning all your panels. That's fine, do that. But you need to get under the panels. You need to see those connectors that aren't visible to the drone. And you need to see what's going on around the grass level underneath those panels. So the drone is fine, but it's not going to prevent all these fires. So maintain the electrical equipment, do dissolved gas analysis. That's for the transformers. And like I've said before, I've got another entire video on the channel about transformer risk management and how to deal with and read dissolved gas analysis. All right. Following along with the loss control, getting into those inverters, the transformers, and the batteries. Like I've said, keep them cool, clean, tight. They're not going to be a problem till they get old. Okay. Now the racks, keep them lubricated and make sure you have spare parts. They are very hard to get in a loss situation when you need them quickly. We will get right into that because we had a loss example where that happened, the $50 million event. There was about 800,000 panels at this solar farm, and about 300,000 of them were visibly shattered by the hail. And the hail was anywhere from 3 to 5 inches across. And again, not every panel was destroyed. So what happens when you have a string of 20 and 12 of them are destroyed and 8 of them are not? The adjuster says, we're not going to pay you for those 8. Well, we can take those 8 and 8 more from another string that aren't damaged. And if we can find enough of these non-damaged panels, we can start reconstituting the facility. Well, we wanted to buy new panels, but they just weren't available. The 300,000 panels that fit this solar facility pretty much were about to go out of production. The manufacturer said, you have 1 week to decide, we're shutting that factory down, and if you don't make that decision at the end of this week, you will not get those replacement panels. The new panels that you can get will be taller. You will need to modify your racks in order to install the new panels, skyrocketing the cost of the claim. The insurer still can't make that decision overnight. We lost so many opportunities to get the replacement panels from the market because the decisions in the claim process were so slow. So the next thing we had to do after we couldn't source them right away was reconstitute. And that's where we started picking and pulling and saying, can they work? Well, that brought up the big question, are they microcracked? Because if they're microcracked, we're temporarily putting them in there. We're not permanently putting them in there. And if we're not going to permanently put them in there, why spend all the time and effort to go through all this if it's not going to really make a big difference? So we needed to know, are they microcracked? Well, it turned out with 300,000 panels trying to figure out which ones, there was a lot fewer of them that were needing testing to determine if they were microcracked than 300,000. That's how many were shattered. I say there were a lot fewer, but there were 800,000 there. So possibly there were more that needed to be tested. We never tested them all at the factory. We ended up having a contractor develop a testing system that could be delivered to the site in a panel truck. And we were able to take individual panels, put them in the truck, test them, determine if they were microcracked or not, and then put them in a reconstituted string. So we were able to go ahead and get that project running. These are some of the things you need to think about in large solar losses. On-site processing, like we just covered, that is when we can do that testing on-site and not have to send these things off-site. Because by the time you send a module to a manufacturing site to be LCD tested and then receive it back, you could have bought a new module. And everybody knows that. So this whole concept of the testing cost has to be controlled and limited. It can get out of hand to the point where you're basically into a replacement cost just because of testing. So bringing a testing van on site really helped us there. All right, we talked about the potential for microcracking and why it was significant. And again, some policies don't cover it at all anymore. It's a total exclusion. Others will say if you had 10 modules in a string and you had 7 of them visibly destroyed, the other 3 can be replaced on the assumption that they're damaged. They're not really saying that it's microcracking or what, but they're just saying that in this policy, 7 out of 10 is enough to get the entire string replaced. All right, moving on from hail. We've seen underground cables during construction or right after construction. This is a common area to see some problems in solar facilities. They carry a lot of load. If they nick up against a rock when they're installed, if somehow the insulation is rubbed or damaged, then we see problems with ground faults in underground cables. Sometimes that ground fault can be on your side or on the utility side. So just because your transformer doesn't operate and all your cables are good, it doesn't mean that the utility's incoming power is good. We had a situation where 2 out of the 3 phases were bad coming into the facility. All right, and transformers. And like I've mentioned before, transformers are a problem. They're the bottleneck of the facility. So when they go down, the whole site goes down, unless you have, like I showed you in the earlier picture, there were 2 transformers being set up for that solar farm. That's great risk management. It's great to have 200% transformers. A lot of times we see maybe 260s, 260% transformers, so they can carry a little bit more of the load, but they're there basically as a installed spare partial backup. So now with that, just thanks for sticking with it. And if you have any questions or comments, that's what we're here for. Put them down there in the comments. Let's get a dialogue going. We'll talk some more about solar. Let me know more about what you'd like to hear in the solar risk management arena, and we'll catch you on the next one. Thanks very much. Bye.